video, we talked about Charles' law and Boyle's law. Now we're going to talk about Gay-Lussac's law. So previously, pressure and temperature were held constant. So now we're going to have volume stay constant. That means pressure and temperature will change. Looking at this diagram, I can see that temperature was 200. I increased temperature to 400. Remember, increasing temperature increases movement of molecules. So temperature increased. What happened to pressure? Well, pressure went from 1 atm to 2 atm, so pressure also increased. It's increasing because I'm having more collisions with the wall. Remember, pressure is the number of collisions. Temperature is movement. So as temperature increases, it makes sense that as we move more, we're going to run into the wall more. So as temperature increases, pressure increases. Remember, direct, indirect. Direct means I go the same direction, whether it's up and up or down and down. Indirect means we're going in opposite directions. Here, increase, increase. Is this direct or indirect? This is a direct relationship, very similar to Charles' law, which is also a direct relationship. So when we draw our graph, should it look like the one for Charles or the one for Boyle's? It's going to look like the one from Charles because it's a direct relationship. So as temperature increases, so as I increase temperature, my pressure will also increase. The formula will also look like the one for Charles, which means temperature is on the bottom. Instead of volume being at the top, we're going to use pressure. It's kind of like in math, we have rise over run. It's our slope of our line. So pressure 1 over temperature 1 equals pressure 2 over temperature 2. Comparing these, Gay-Lussac's is very similar to Charles. They're both direct, they both have an increasing graph, and they both have equations that are in a fraction form. So remember, we were looking at temperature and pressure. Let's look at question 10. A sample of gas at 1.65 times 10 to the second mmHg, that's my pressure, so first pressure. Inside a steel tank is cooled from tells me it's my first, so this is my first temperature. 2 tells me it's my second temperature. There's something tricky about these temperatures. What's tricky about 240 degrees Celsius and 0 degrees Celsius? If you said degrees Celsius, you're correct because it has to be in Kelvin. So I'm going to add 273 to both, and that means T1 is now going to be 513 Kelvin. 0 degrees Celsius is now going to be 273 Kelvin. So I like pictures. So we have our first tank and our second tank. Our first tank is 513 Kelvin. Our second one is 273 Kelvin. Pressure, 1.65 times 10 to the second. Well, if I put that in my calculator, I find that it's times 100, Or I could have moved over my decimal 2 places because it's just scientific notation. So 165 mmHg originally. I see that temperature has decreased. I can predict that pressure will have also decreased because they are in a direct relationship. So we're going to use P1 over T1 equals P2 over T2. Plug in our values. P1 is 513 over 165 equals P2, which is 273, over T2, which we don't know. We'll cross multiply. So I have 165 times 273 equals 513 times T2. I want T2 by itself, so we'll divide both sides by 513. We'll plug this into our calculator. Remember, across the top is multiplication. Going down below is division. So I'm going to put 165 times 273 divided by 513. I get my temperature to be 87.81 Kelvin. So did temperature decrease? Oh, sorry, this is not Kelvin. Woo! Pause. I messed up. Where did I mess up? If you said I messed up because I plugged in temperature instead of for pressure, you're correct. I should have plugged in 165 over 513 equaling P over 273. In which case, I could have just multiplied both sides by 273. So, 273 times 165 over 513 still ends up with the same answer because I misplaced them. I switched them just right. So if you switch, sometimes it works out, sometimes it doesn't. This time it did because I had switched the top with the bottom, so when I cross multiplied it fixed it. But be careful because obviously we can make mistakes. The unit of this will be mmHg because that was my unit of pressure. And yes, it did go down like I predicted.